Solve the system by substitution or elimination. If the system is inconsistent or has dependent equations, say so. We have the system negative 5x plus 2y is equal to negative 4, and 6x plus 3y is equal to negative 6. Let's start by identifying these equations as numbers 1 and 2. Now, I'm going to choose to use the elimination method, and I'm going to eliminate this variable x. So we need to fix our coefficients out here so that they are opposites of each other, okay? Additive inverses. So let's multiply equation 1 through by the number 6 and equation 2 through by the number 5, creating coefficients of negative 30 and positive 30. Here we go. Equation 1 then becomes a negative 30x plus 12y is equal to negative 24. And just a note to self, that was 6 times equation number 1. For equation number 2, multiplying through by 5 gives 30x plus 15y is equal to a negative 30. And as a reference, that was 5 times equation number 2. Now we're ready to add. Our x variable cancels. Our y variables, when we add there, we get a 27y, and that's equal to a negative 54. Dividing both sides by 27 gives y equals negative 2. Now let's solve for x. And I'm going to go back to equation 1, which was negative 5x plus 2y is equal to negative 4. And let's substitute y equal negative 2 into this equation. Thus it becomes negative 5x plus 2 times negative 2 is equal to negative 4. That's a negative 5x minus 4 is equal to negative 4. Adding 4 to both sides gives a negative 5x equals 0. Divide both sides by negative 5 to get x is equal to 0. Now, it's always wise to check your solution back in both of your original equations, and if you do that, a check does verify that the solution set is x equals 0, y equal negative 2.